Okay, 7.EE.2, this is 7th grade Expressions and Equations 2, Video 1, Rewriting Linear Expressions, and I want to touch a little bit on the standard right here. We are going to take these linear expressions, rewrite them in a context that would be able to shed a little bit more light on the problem and how these quantities that are in it are related. So before we begin that, let's double check our notes and make sure that we have these terms written down from a previous video. And let's practice a little bit with combining like terms. So following some order of operations, combining like terms, and then finding out whether or not these two expressions are equal to each other. Expression 1, it says 10 times the quantity of 4x subtracted by 5x. Is that equivalent or equal to expression 2, which is already simplified to 35x's? All right, using our multiplication, first we have 10 times the quantity of 4x's. So 10 times 4x would be 40x. And then we are subtracting 5x. And 40x minus 5x is equal to 35x. So is expression 1 equivalent to expression 2? Yes, they are equal. And it says, if so, explain how you determined your answer. Well, I was able to use my order of operations. I combined my like terms, my x's, and I was able to notice that we have equivalent expressions. All right, here's another one. Please pause the video and see if these two expressions are equivalent. Okay, we're back. Here it says 2/5 multiplied by 4x subtracted by 3/10x. So we're going to have a little bit more work to do. Let me slide this down here and let's get some fraction work going. So we have 2/5 times 4x. And that would be 4x. We could put it over 1, and that doesn't change the value. It still means 4x. So 2 times 4x is equal to 8x over 5, subtracted by 3/10 x. And now we need a common denominator to make sure that we can subtract these fractions. So the common denominator of 5 and 10 would have to be 10. So we have 10, and we're not going to be changing the second fraction, so we'll leave it as 3/10 x. All right, so how do we get from a 5 to a 10? Well, we multiplied by 2, so let's multiply the top by 2, and we're going to get a 16/10 x subtracted by 3/10 x. All right, let's subtract our numerators. We're going to get 13/10 x. Is that the same as 13x? Well, if I were to simplify 13 over 10, we would divide the numerator by the denominator, and we would get 1.3x. So these are not equivalent. I don't have the same place value. I have a whole number 13.0, and I have a decimal mixed number here of 1 3/10 x. So these are not equivalent. They look kind of the same, but they're not equivalent. All right, here's a long word problem, and this is basically what this standard is all about. It says 2 different clients are bidding on the same house. Client number 2 bids 8% more than client number 1. The expression x plus 8/100 x can be used to determine the amount that client number 2 bid. Write an expression that is equivalent to the given expression and explain how it might be more helpful in determining the amount that client number 2 bid. That is a lot of wording. What I'm going to do is I'm going to take just an example, and I put a number to this. There isn't a number in the paragraph, but I just created one, and you can do that with word problems. Try to create something some numbers that you can use to have a problem make sense. All right, so client number 1, I said, let's say they bid $200,000 on a house. They really, really, really like that house and they want it. And then along comes client number 2. This person also is in love with this house. Now, they're going to have a bidding war. And if client number 1 says, I want that house for $200,000, the second client said, well, that's fine, but I'm going to bid 8% more than you. So if I'm putting that to numbers, it's going to be client number 1's $200,000 and client number 2, so this is client number 1's bid, and client number 2's bid said, all right, I'll take that $200,000 and I'll take an additional 8% of it. So 8% of $200,000 is a multiplication problem. Of means multiply. All right, so here is your setup expression. Client number 1 was their bid called X, and client number 2's bid was 8% of client number 1's, which was X. And we have this expression that has multiple values for X. So if I were to simplify this and make this easier, I could make this a 1X added to a 800th X. And if we combined our like terms like we did on the last couple screens, I would have 1 and 800ths X. Okay, so would it be easier to take the purple line and do the multiplication of 8% and add on the $200,000 to it? Or can I just take the 1 and 800ths X and replace the X with the $200,000? So we're looking at equivalent expressions and determining that this one is going to be a lot easier to manipulate or use than the purple line right here. Okay, now if you wanted to solve that out, we could get out a calculator and multiply $200,000 times 8%. I'll just tell you right now that is $16,000. So client number 2 actually bid $16,000 more than client number 1. All right, now the last part of this says, write the expression and then explain how it might be more helpful in determining the amounts. All right, so I wrote a little paragraph down here for you. It says, this expression 1.08x, I'll just tell you right now, 1 and 800ths x. This expression makes it easier to calculate the amount that client number 2 bid because I simply have to multiply the amount that client number 1 bid by 1 and 800ths to determine the amount that client number 2 bid. So again, that's just taking this entire line, the purple line, out of your thoughts and just combining your like terms in the expression and multiplying it by your $200,000, which is your X, your starting value from client 1. Whew. Wow. We will take this in class and definitely explain this further. This is the main part of the standard that I really want you to grasp. All right, the last few slides on here are basic problems in which you're going to practice again reading a graph or reading pictures. In this case, we have a perimeter problem and determining what expressions can be built and then what one would be the easiest to use. All right, rectangle. We have two values of your side lengths. We have a width called W, and then in the problem it says we have the width, which is 6 inches longer. So the length is 6 inches longer than the width. And if we're finding the perimeter, we know that the perimeter is equal to the sum of all of the sides. Sum, adding up, of all sides. Okay, now if I were to just write that out completely, the perimeter is equal to your width added to, well, there's another width over here, added to, we have this W plus 6, that's the length, and then added to another length, and there are your 4 sides. That is a very long expression. So if I were to know what the width is equal to, would I want to take that width and plug it in all of these spaces, or can I combine my like terms and use a simplified expression? Okay, so the perimeter should be equal to 1 width, 2, 3, 4 widths. I'll even circle them. 1W plus 1W plus 1W plus 1W is equal to 4 W's. And then we have our constant terms. We have a 6 plus 6, which is equal to a plus or positive 12. I personally would like to use the second expression. Even though they would both work, it just seems like the second expression would be an easier one to work with. All right, last one. It says rewrite this expression in 2 different ways. So it looks like we are going to be expanding this expression, and we've already taken some time and talk about expanding expressions, and I'm going to show you 2 ways we can do this. All right, the first way is your basic distributive property. So we take 6 and multiply it by 1/2 x. Well, 6 times a half, I'll even set it up for you as fraction work. Some of you might already know that answer, but 6 times 1/2 x, and then we have 6 multiplied by 3y, which is a different variable. That would get you here. And then the last one would get you 6 multiplied by -8. Okay, so we would, expression number 1 could look like, well, 6 times 1 is 6 over 2, which is a 3. So we have 3x plus 18y minus 48. If you just follow all of your operations down the line, we can combine this now and see how it looks. We have 3x plus, because it's a positive, 18y, positive times positive. And then we have 6 times -8 is a -48. So there is one way that we can rewrite this expression. And then the second way, I guess we could just set them up as all fractions. How about 6 over 2x plus 3 over, no, hang on a second, plus 6 times 3, we'll keep it as, let's keep it as 6 times 3. Hey, give me that pen. Plus 6 times 3y, and then we can do minus 6 times your 8. All right, so all I did there was I used my distributive property. I just I didn't simplify anything. I just wrote it out. Okay, so um, here are your two different ways of writing this expression, and I'll tell you, there are many other forms that these expressions can take, and I'll get into that more in class also. All right, in your journal, I would like you to define the given terms on page 2 of the flip chart. If you haven't already done so, I believe we've already done that in a previous video. Write a few sentences on what you learned and write some questions down. This was a pretty intense video, a lot to this standard when it comes to combining your like terms and applying it to that real world problem with the bidding war. And I will see you in class.